So I'm pulling in Obi's code. So we have this part. So let's see, we have to fix it because it's in a package. So just use this quick fix and it adds this to it, specifying which package it's residing in. So let's look at the question. So let me pull it up. Let's see. So I said, let's see, write a function that will, was it this one? All right. So I said, write a function, Java program that will replace the system.out print. The goal is to use the function whenever you wish to print something on the console. Name the function print to console. So yeah, this is pretty straightforward. Yeah. Yeah. So this looks good. It's quite easy. So that works. So you can imagine those assignments we did before, right? So if I go back to some of those assignments we did, I'm gonna pick I'm gonna pick say let's look for nonces. So you see all of this parts where you're using system.out.print. Now if you had this function, you could just call it, just put it here and put the text and it would print that. See? So this is pretty how functions work indeed. And you see, of course, uh, yeah, use the right indentation makes it easier to read. But yeah, pretty straightforward. I like it. This is actually correct. Let's look at the second one. The next one, I mean. It says write a Java program that has three methods. You may name the method what you wish. Each method should take two parameters. The first method should be used for addition. Second one should be used for subtraction. Third one should be used for division. So I have these three methods. Okay. Let's see. So I think Obi, you have a total here. Let's see, what are you using total for? So what I actually expected is for you to test all three of them. But does this work though? Let's see. Does this work? So if I run this, it works though, but we could make it clear. So now you just returned 9.2, but yeah, it's not really clear. So I would probably specify, um, I'll probably specify it in a different way. So to adjust it, I would say rename this, make it more intuitive, right? Because technically I gave it away. One is addition, subtraction, and division. So you could just use the same name. And this is kind of a calculator. So you just make this add. Minus is also good. We can also say subtract and divide. So that's good. So here you can now put your numbers just to make it much more intuitive, right? So this is good. And remember, you're returning values. You're returning floats, and all of them. So you could be like, you could do something like this and say in the value one. So that way it becomes clearer. You select something like 50 in value two. You can say 10. Then here you now say you say you can do something like, sorry, not int because you're returning float, right? So make this a float. Then here, then we do something like this. We say, uh, can say variable, right? So we say float addition answer. See, now if you're reading the code now, you know exactly what that is. So we do add. So now you can do your value one and value two. So you see now, Obi, if you're reading this code now, you know exactly what it's doing. So you're like, oh, okay, there are two values. I'm calling the addition, and the answer will come here because this addition will give a return value. So you go to the next one. That was subtraction. Say subtraction answer. So we say subtract. We can also use the same value, value one, value two, or you use a new value if you want. It's all on you. Then we go to the third one, float, division, and I'll say divide, answer, divide, and then we use value one or value two as well. So now, Obi, if you wanted to print it, you can now come here and do something like this. So it becomes much more readable. You can say addition, and you add your variable addition answer. So let's duplicate this three times. So this will be subtraction, subtraction answer, and divide answer. Subtraction, divide. So if you look at this now, it looks a lot more clearer what you're doing. So now I know you have two values. You have all of this values being, I mean, your methods are used being put in this variable because it's returning a value, right? So you're returning, and you also specify the return type float. And then, yeah, when we run this now, we print it out, and you see we have very good organized answer. So that way I know, okay, the additions. And of course, you could also make it in such a way where you ask the user to put in two values, and then you have a calculator that people can really use. But good job, good job. I like it. Obi, do you have any question with the update I just made to your code?
No, it's really clear. I don't have any question.
All right,
No questions.
all right, great. So let's go to non-source code. I'm gonna pull that in right now. Right, non-so. All right, refactor. Okay, so let's see what we have here. So we're gonna fix this up. Yep, and set package. Good. So let's see. This is pretty straightforward. Yeah, very good. Always a good idea to format your code properly. So that's good. This looks pretty much the same as what we saw. So great. Like I said, now that you have a method like this, that's the beauty of a method. You can use it everywhere. Now you can say instead of doing system.out.print, take for example, you find system.out.print too long. Like, oh, I have to type system.out.print, right? You could just do
Hmm.
something like this. Just say pp. So your
Wow.
pp here. So that means
PP
you
here.
will just be using it everywhere. So if I run it now, so you see that? So I can do something like this. Um, take for example, I said something like I created a variable. I said int 50. Sorry, int num is equal to say 50 plus 100 plus 100, right? And then you're like, oh yeah, I want to print this out to the user. So instead of saying system dot out of print now, you just do pp. You just say num and okay, yeah. So it's not taking it because num is not a string type, right? So if you want to convert it a number to string, you just do something like this. Let me say, I think it's actually string dot pass int, string dot pass. No, I think what was that again? Number to I think we've done this before. Um, number dot. How do we do that again? Number dot. No, sorry. I think it's. I was expecting it to be like string dot pass. I think we have a passer in the string. Let me see. Value of. Let's see format. Okay, so you see. I cannot remember. So we go to Google, we say Java, convert into string. So yeah, that's what I thought it was, but I didn't find it. Dot. So of course we can use value of, but I also thought we had toString. ToString. Oh, okay. I get it. So this was supposed to be integer dot, because the number we're trying to change is an integer. So you say integer dot toString, and then you give it the number. So it converts it to integer. So this works. So it gives us our 150. So let's get rid of this one. We run it again. So it gives us our 150. But also we saw that you can also do string dot value of. This also converts it to string. So you see that also works. So you see, using methods. Now imagine we wanted to do that many times. So with the method, you see we have 150 many times, and this is because it's not even ln. So if you wanted to do print ln, so we put the ln there so it doesn't stay on the same line. And then if we run it now, you see it puts it under each other. So you see the beauty of functions or methods is that you have one code and you can reuse it multiple times. You can reuse it. Now imagine you have to. This is not a very yeah. It's not really a very good example where you'd be like, okay, um, writing system that auto print is quite easy to write, but sometimes you have like lots of logic that needs to happen. Now imagine you have to do this every time that you wanted to print the output. So if you just put it in a function, you can reuse it multiple places. So that's the beauty of this. So yeah, so that's good. Thank you, Chinonso. This was pretty good. Just wanted to show you guys some extra cool stuff. Let's see. Let me go forward. Yes. But remember, we are talking about object-oriented programming, and what you're learning here is, you know, the functions are actually doing something. So I mean, sorry, I use the word functions and methods. They're the same, but methods, I'll probably stick with methods. So methods perform an action. Properties are the characteristics of a class. So you have a class, print to console, and this is an action that gets performed if you call it. So let's go to the next one. All right. So this is we have an addition. All right. They're all returning int, which is nice. Okay. Then we have here a custom print line. Wow, this is, yeah, I think you're using that whole ideology I just talked about. Because now, instead of using system to print, you can just call your custom print line. Wow, this is it. Oh, see? Nice implementation. Good, clear, and exactly. You're catching, you're picking up the result, and you're using your custom print line to print it. Yeah, this is pretty much what I just explained right now, and that's it. Really nice. Really nice. So let's look at Ifine's own stuff. Are there any questions pertaining this? Okay, no questions. So let me try to get Ifine's assignment. All right, just give me a minute. All right. Oh, I think I put it in the wrong place. Or not? Oh yeah, I did. Let's get rid of this one and let's open up. Oh, I think I. Okay, no worries. Let's fix this. And we have this one, calculator fixed. All right. So what do we have here? Wow, that's interesting. So if I has two classes, So, which is also very interesting. So, if I created two classes and he put these two classes in the same file, so this is also allowed in Java. So you have class calculator up here, and you also have another class up here. So this is allowed. I would strongly discourage it though. Try to put your classes in separate files. It's more of convention, but Java does not have a problem. Java is very smart. Java is gonna know, as you can even see, IntelliJ is also pretty smart because it saw that there are two classes in here. So let's look at the first class. If I created a custom console, and yeah, so as we can see, let's run it and see. I think it's very familiar. He's using that to print. Um, what is he printing? He's printing his name, Richard, and let's see, calculator to add. Okay, so okay. I understand what he's doing. So what he's actually doing here is he's using one main method to run both classes. So that's good. So here he so the first line, this print to Richard is actually in the same class as the assignment class. So it's just a method inside this whole class. So he calls it up here, and that prints Richard. And then he has a calculate class, and he calls the class also here. But the what I realize is he is calling the class directly, so he just did calculate.add, and it still worked. Could you see that? So why is it that he did not create an instance of a class? So remember in um, our last meeting, let me pull up the sheet again. Uh, so let's go back. Let me go back to this guy. It's not in the slide. Is that possible? Okay, that's interesting. So first of all, let me ask you guys a question. I thought it was in the slide. Let me just scroll up a bit. Okay, it's not. So how do we create a new instance of a class? Because I'm seeing he's not creating a new instance here. So okay, fine. I'm gonna. So normally, if you want to create a new instance, since you have another class here, so remember I explained classes to be like the classes is the blueprint, and when you create a new instance, you actually create an object. So here, normally what you would expect is he will say something like you create a variable of type. So this is of calculate. So to create a new instance to look like this, calculate. Then he'll create a variable for that, cal. You can call it cal, and then he'll now use the new keyword, new calculate. And then before he can access the add, he can now do something like calc dot add and all that. So, but why is he not doing this? Because now he didn't create an instance; he just started using it. So, can someone explain to me what's going on here? Why did he? Why is it he did not create a new instance like I explained here? That you always have to create a new instance before you can access the methods in it. So he has a class here. He has three methods and he just used it without creating an instance. He just said calculate.add, calculate.subtract, calculate, and it still works. Look at the result. All right, if I do you want to explain it to us, what happened here and why is it still working?
Yes, sir. First of all, I created an instance, then tried to call the first method. Like it was giving me that squiggly line on there. So I hovered over it. IntelliJ suggested I
So why
do it
why
like
is it
this.
working? That's the point.
So I guess like because I have the class in the same file with the
Okay,
main
so let's
method.
try it then. Let's see. Let's see if your theory is correct. So we're gonna create a new class and we're gonna call it calculate. So you see now is a totally separate file, right? We're gonna take your calculate. I'm gonna delete it out of here, and we're going to put it. Sorry, where are you again? That's this guy. We're gonna put it here, and let's run it. See, it's still working. So your theory is wrong. Try again. Anyone that has a different idea,
I think the class is I think the class is
which
public.
of the classes?
Is it because public? The
Yeah,
calculate
it's
class.
it's public by default. So if I didn't put anything, it will be public. But yeah, public. Okay. So I'm going to explain it. And does anyone have any idea? But I hope you guys are seeing what the issue is here. Or not, it's not an issue, but you have to understand what's going on. I explained last time that you have to create a new instance to be able to access properties of another method. Like he has this property, this method, but he did not create an instance, and he just it's still working. Like it's either it's either I didn't know I didn't explain it properly, or there's some magic happening that I didn't tell you guys. So it's good to know why. So Chinonso, shoot, see Chinonso's hands up.
I think IntelliJ has is smart and it has a way of knowing what we're trying to do.
That's true. That's true. But the thing there is whatever IntelliJ suggests is something that Java allows most times. And but it's always good you understand why is that working, and because that's what's going to make you a good programmer. You have to be like, okay, I sometimes IntelliJ might suggest something like, I don't agree. You understand? So, but I'm going to explain it because truthfully, I didn't explain this part to you guys. Now, so if we look at this class, the class is a public class. It's nice, but look at this keyword that he's using here, static. And if you look properly back on the main method, we also see the same keyword here, static. So what is a static class? Because you can also put static here. If I put, I can say public static class. Let me see. It's not working. Okay, sorry. I think I'm thinking C sharp. So we leave it a class like this and you put static. So what does this static do? So what static does is, let me go back to this page. So remember, every part of this car is an object. So take for example, we create an object of wheel. If you make it static, what will happen is Java will will perform like this action for you. Take for example, okay, say this divide, it will perform because it's static. It will just perform it, and when it performs it, um, it is more like how would I explain it? Sorry, just give me a minute. So, um, what was I saying? So when it's static, it doesn't create an instance for you. It just gives you the answer you want, and it just goes away from memory. It doesn't really keep anything. So it's more like saying, um, it's more like think about it like a traveler. So you have a store. Okay, let me use an analogy. You have a shop where um, you sell computers, right? So think about it. You have a shop, a store. You sell computers. You have two types of customers that come. And okay, yeah, and that your store is located close to the airport. Get it? Close to the airport. So because it's close to the airport, you get two kinds of customers. One of your customer are customers that are traveling, and the other type of your customers are customers that live around your neighborhood. So what's the difference between these two customers? Now the first customer, which is a traveler, buys something and you never see him again. He just bought it because he needed it while traveling. So there's no relationship. I mean, you be nice to him and you say, "Oh, thank you, bye," and that bye is probably forever. You never see him again. Whereas the other customer, you keep the customer relationship. He goes, he comes, he goes. He can always jump back and ask you, "Hey, do you have this? Do you have that?" Because he lives around the neighborhood. So he is the relationship between both of you that is the producer and the customer is quite yeah, he can always come back and you guys are familiar with each other. Now let's put that to this. So when you create a static method, a static method is like a traveler. It gives you what you want and it goes away. It doesn't remember you even. Something it might travel, it doesn't even remember the name of your store because he bought it because he needed it. So the same thing when you use a static method, nothing gets maintained within the class. It just gives you what you want and it goes away. So you cannot say for instance, if I had a value here, value, if I had let's say, let me just say int tell me, that's the name of the variable. I'll say is 0. And for instance, after you printed subtract, maybe you now turned the tell me, you now say tell me uh, is equal to um, say just say 10, just for example. Let me see. So yeah, this has to be a static because I'm using it from a static. As also a rule in Java, if you're using from a static method, you have to make sure this is also static. So I'll say public. Let me just put this public static. So if I made this tell me 10 every time I call subtract, because if I made it static, once this subtract is done, I can no longer gain access to tell me it's gone. It's just the traveler just did what he did and it's gone. I can't I can't be like, okay, now that I'm gone, oh let me get tell me. No, you've performed this subtract and it's gone. There's no relationship. It's not remembering anything. So statics are used, and when you make something static, you don't have to initialize, create an instance of your class because it's a traveler. You don't need to. So I'm equating creating an instance to be like, okay, now we have a relationship we can maintain. Now I can find ask stuff. So let me create a different one. So I'm gonna create a subtract again, but this time instead of me making it static, I'm going to not make it static and I'll name it subtract two because you can have two of the same names. Now check this out. Look at the difference. So if I come in here, um, if I call, so from here now, you see, on this subtract, after this is called, I cannot do anything. I cannot access that tell me variable from this. This is done. So you see, it doesn't return anything. So there's no return RR. Let's just do, it doesn't return anything because it's a void. Good, but how do I get this? This is like, let's say this is like the coupon or the thank you that the seller says, tell me, or let's make it thank you. Thank you. Maybe that'll be, let's make it thank you, just to try to fit it into the analogy. So where's the thank you? I cannot access the thank you. Let me make this one also thank you. So because if I use the static method, you see, the static method just does what it does and it's gone. I can't access thank you. There's no instance. It just calculates and it's gone. Where is my thank you? I don't have any thank you because it's not. I didn't create an instance of that class. And a static method, you need it when you want to use stuff like that. Like you don't want to maintain anything. You just want to use it and go. But whereby you have a class where there are different things happening in the class. Maybe when you change this, this change. When you change this, that change. Which is what you see here. Subtract got called, but when subtract got called, something else changed. See, thank you moved from 0 to 1. I mean 0 to 10. So there's a relationship happening there. Something you update something, something else gets updated, this gets updated, and you want to have access to all of those things that's happening in that class. Then it's better you use create a new instance. So you see this new instance I created here. Now check this out. I'm going to call the same calculate. I'm going to call sorry, I'm going to call the same subtract, not the same, but the other subtract I made, which is subtract two. So and how do you call it? Remember, you use the instance variable. So that's cal, so which is what you see here, and then you put a dot, Then you see I have access to subtract 2, but see I don't have access to all the static variables. See, IntelliJ can't even find it because they are static. But the one that was not static, which is this one, subtract 2, it's not static. See, now I have access to it when I put a dot. So I can say dot subtract 2. And then I can put my number, 6 and 2, right? Now check what happens. So I'm just going to comment this out for now, just so that we can concentrate on this one. So if I run this, let me see. If I run this now, um, let me also comment out this one so it doesn't, because I want to focus on this. So if I run this now, you see it gives me the answer 4. Now, even I can still access thank you now. So I can now say Carl dot thank you. Where's my thank you? Oh, let's see. Is it public? Oh, it is. Oh, okay. So that's another thing. So I'm still not able to access it because it's static. So I have to get it away from static. So I made remember I made it static because I wanted to show you guys the example from here. So I'm gonna get rid of this and I'm gonna remove that static because it's not a static. It's I want it to be part. Oh, my computer just tripped. All right, I think I have to share my screen again if I'm not mistaken. Great. So now you see I had to make that remove the static from the thank you, and then if I go back to my calculate, my assignment, yeah, then check this out. Dots. See my thank yous there. Thank you. So now I have access to it. So what does it do? Thank you actually returns. It assigns something. So I'm just gonna do something like this and say system dot out. Oh no, he has a method called print to console. So we're going to return that. And of course, because it's an integer, let us use a string converter. So I'm going to say string dot thing value of, and that way we can get it. So check this out. We run it and we get 4 and the 10, which is the value. And that's that relationship I'm talking about. So we created a new instance. So this is just what we did. We created a new car, and because we created a new car, we have access to the wheels, we have access to uh, the the lights, we have access to everything that is in it because we created an instance. And this instance, we can now reuse it. We can maintain it. We can call the next. Can say calculate dot. What's the next one? Okay, yeah, you don't have anything there that is not static. So yeah, that's just basically it. So the point I'm trying to make here is, so let's reiterate. So the point there is one, when you create a static method like he did here, you don't need to create an instance of that class to be able to access it. You can just access it directly the way he did it here. So I'm going to comment my own part out again and look at how he just accessed it directly. And IntelliJ is right. Since you are if you are generating a calculator, because this is a calculator app, yeah, as long as you don't want to remember anything, the person just wants to add a static method will be fine. Just give the person the answer and bye. Answer bye. I don't need to know anything. Bye. But take for example, you're designing a banking system. You're designing maybe this class name is bank, and you know when someone adds fund or money to their bank, you want to remember it. You want to store it somewhere. If someone removes money, you want to store it somewhere. So making it static would not be a good idea because when you have a method that says add money, you add money. The person adds 5. You want to also access another method called show me my balance. So if you make it a static method, you don't have access to show me my balance because add money just adds money and goes away. It doesn't remember anything. So that's the difference. One more time, iterate. Static method, you don't have to create a new instance of. Um, Whereas if you have a non-static method, you have to first create an instance of that class and use that instance of that class to access the method. So that's what we do here. How do you create an instance of a class? You use the new keyword. So you create a variable of it and use the new keyword, and then that instance gets stored inside your variable. And with that instance, you can now start accessing all the non-static components or non-static methods or properties. Again, let me be clear. This is a method. So if I say method, method is something that performs an action, and properties are attributes that belong to the class. So you see, this does not perform anything. This is just like saying the characteristics. So if I could also say uh, what is the color of the calculator. I can say public string color. Yeah. So these are all properties that belong to this calculator. Maybe the calculator is black. So it's just like saying, yeah, what is Darlington's property? I have dark skin, but what can I do? I can punch, I can fight. That's an action. That's a method. Punch. So if you say punch, I punch. So that's a behavior. But property is just, yeah, what are you? Yeah, I'm, you know, maybe I think I'm like 8 feet tall or something like that. I'm practically a giant, you know, and those are my properties. So I'm dark skinned, you know, all this kind of stuff. So know when you use the term, try to know the difference. Methods perform actions. Properties are characteristics, like something that belongs to. So I'm using that term a lot, so you guys start getting used to it. So yeah, so these two work. This is because this is a static method, and this subtract two is a non-static method, and because of that, you have to create a new instance, and you have to call it like this. So if you had done it like this, you also wouldn't have had a problem. The only problem was because you made the classes static. Couldn't. So if you make your class static, you cannot access it from the instance of the class you created. Are we clear? Is there any question? Fine, do you have any question? Okay. All right,
Okay,
so
sir.
pretty good, pretty good, pretty good. So let's see what's next. I'm gonna pull out my notes. Just give me a minute because we want to move to something that might be a little confusing, but you guys have to stay with me. Very important. Um, okay, so this is what we're talking about. So we're gonna be talking about the concepts of object-oriented programming, and the concepts of object-oriented programming knows there are four very popular concepts that an object-oriented program must adhere to. So if you want to know if your software implements object or you're using object-oriented style in developing your software, these four behaviors or concepts must in some way or form exist within your software. So we're going to look at it one by one. So before we do that, um, let me give, let's see if we can write a small program, right? So everything is going to start making sense. So I'm going to create a class. What would be the best thing to create? Let's see. Okay, let's use a car. A car is probably very easy. Oh yeah, I have one here. Car. So I'm gonna strip this all out so we can start from fresh. So we're gonna call this one. This will be the cars, and you see, it has no main method. It also has two parameters, proper parameters. We're gonna take that out, so it's just empty now. Then I'm going to create another class. I'm gonna call it a car constructor or a car manufacturer. Manufacturer. and this is where our main method will reside. So I'm gonna say public static void main string args, and did I make a mistake here? What's going on? All right, what's the bug? Uh, could also no, doesn't really matter. Oh yeah, so I have a class in a constructor, so that's so this is the constructor and I'm putting the method inside the constructor. It's not supposed to do that. So I'll take that out. So that's it. So this is my main method, and we're just gonna create a new instance of our car. So this is our car. Remember, our car is just empty, it's not doing anything. But let's create a new instance. So we're gonna say car. We're gonna call this car with a small letter is equal to new instance of our car. So we have a car is now being formed, is being created inside this variable car instance. So let's look at this concept one after the other. Encapsulation. So what exactly is encapsulation? So the concept of encapsulation is about, hiding implementation details of an object from the outside world. So take for example, guys, I'm sure some of you have a car, some of you have driven a car, and if you've not driven a car, at least you know how a car looks like. So let's take a picture of, let's go back to that our car picture or image. Where is it? This guy. So when you buy a car, right? Except for those who are really car freaks, but if you buy a car, you really don't care how the engine is working. All you know is there's a button I need to press, or there's a key I need to turn, and it should turn on. And that right there is encapsulation. That's why you have the bonnet. It's closed. It's not your business. You don't want to know that when you turn the key and what fuel gets poured into something that's in somersaults and explodes here, that one explodes and turn this key, this thing turn to that, and then it now started. You don't care. Like even me, I don't care. I really don't. I like car a bit though, but I don't care. The only thing I care about is when I get into my car, I turn my key, it should turn on. So that right there is encapsulation. The manufacturer has hid you from all the difficult and nonsensical thing that you don't care about and only exposed one part to you that you'll be able to press or turn and it should do what it's supposed to do because you don't care. That concept also for you to program in object-oriented programming, you should think in that manner. You should your software should implement encapsulation. And how does encapsulation look like? So what if we had um, this? Let's go back to our app. So let's simulate starting a car. So take for example, we're gonna have a method. So the method is gonna be, we're gonna say public, um, we're gonna say public void because we don't return any something. We're gonna say public void start car or start engine. This is how we're gonna start the car. Now, let's think about the things that should happen. I don't know about cars, but I'm gonna pretend. I'm gonna make. I'm gonna write private. Private. Okay. Let's before we do the private. Say. Let's take for example, four things need to happen before the car will start. So we'll say. Uh, I'm just being fictive here, right? So for the first thing, we're gonna say we're gonna call it um, say I'll say private. I'll give you the variable name called start car stage one. I'm gonna give it a boolean. I'm gonna call it just bullshit. Oh yeah, boolean. Sorry, boolean is false. So the initial state of the car is these stages are not all of them. They are not done. So we have four stages. So two, three, four. So let's see. And then when your car starts, we're gonna run stage one first. So we're gonna say something like public void. So you see, I mean private void. You see, I made it private intentionally. That's where the encapsulation is coming in. So I say private void start uh, stage one. So this is a method because it's gonna do something, and I'll say something like system.out.print. Um, Let me just say um, uh, getting fuel from tank. That's stage one. Then when I do that, I now say now stage one start. Car stage one is now true. That means it's been completed, right? Then I'll do the second one. Go to the second one. Let's duplicate this. Go to stage two. Then the stage two will be maybe what happens when you start a car again. Let me see. I'll just say combustion. I don't know what I don't know. It's irrelevant, but let's just say it because it's cool. So that's the stage two that needs to happen. Let's go to stage three. Create another method for stage three. Let's say car somersaults. Yeah, sorry. I'm a newbie with cars. And then it says stage three through. Then the fourth one will be the fourth stage would then be let's see. Guys, help me out now. What will be the fourth stage? Give me a fourth stage that you think a car that happens under the hood that we don't know about. Who's gonna help me? Who's a car head here? If I come on, give me something. Ubi, nothing. Gotsu, what about you? Give me something. What do you think happens under the hood of a car when you try to start it? Give me one action. Ah, let's say sound turns on.
A
Thank you, my
sound comes
man.
on.
So take a look at this. These are four different stuff that happens when a car turns on. So now I have my start engine. Now pay attention. All of these four function methods are all private, and the only one that is public is start engine. Now check what's going to happen. Now I'm like, when you click on start engine, I'm going to check if start engine one is true and start engine two is true and start engine 3 is true and start engine 4 start stage 4 is true. Now let me put it in different lines for readability, and now I'll open my braces. Now at the top of it, I'm going to also now call my methods. So I'll say start what was that again? Where are they again? I'll say start stage 1. Okay, so these are the methods. I'll say start stage 1, duplicate this 4 times, start stage 2, start stage 3, start stage 4. Then here I'll say if all of these are true, then system.out.println engine started. Okay, let me rename this thing so not to not to confuse it because they all have the same name. So I'm gonna call this I'm gonna call this I'm gonna call this get fuel. Let's see, rename. Where's rename? Refactor. Right. Okay. Let me just. I'll call this get fuel. I'll call the second stage combust. I'll call the third stage somersault. I'll call the fourth stage make sound. Sound. So now I'm going to rename this. I'm going to say first you have to get fuel. Secondly, you have to, I don't know, what's the second one? Combust. Third, you have to somersault. And last, you have to make sound. So remember, each of this function, if we look at them, they print out something, but they also adjust a value. They say they make this start car, like this one says start car becomes true because when you call this function, all of them are false. So it updates this to true, it updates this to true, it updates this to true, it updates this to true. So that when I now run this function and says, first of all, before I can print start engine has started, I have to check if all of these are true. Now, having done that, let me just put trailing lines here just to make it look like it's busy. And let's make this one look grand. Putting some sound effects to it. Make it look cool. So now we've created our car. And this is where the encapsulation comes in now. Now we go to our car manufacturer. Our manufacturer, in this case, which is you, you are now trying to use this car object. You stepped into this car. You want to create a new instance of this car. So look at the encapsulation. You want to start the car. So you now do car dot, check this out. You're not seeing any of those crap. You're not seeing any of the encapsulated stuff. You don't even know that there's a combustion that happens, that there is a somersaulting that happens. No, all I make accessible to you is start engine. And guess what? When we run this now, see, it does all those things. Get fuel from tank, combust, car somersault, stance, and engine started. So this is the encapsulation. It doesn't show you things that you don't need. It only makes what you need to know accessible to you. And every other thing that happens under the engine that needs to happen is not your business. You don't even know that it's happening. You just see one in here. You're like, okay, getting the fuel from tank. Okay, that's fine. Combustion. Okay. Somersault. All right, nice. But when you want to use your car, all you have access to is start engine. You get it? So that is one of the concepts of object-oriented programming, encapsulation. You want to hide things that are not relevant to whoever is going to be using your class. You hide it away. If there are calculations you need to do under the hood that is not relevant to the user, you encapsulate it. And how you encapsulate it is by making it private. If you make it private, it's not seen, it's not accessible. The only things you make accessible are things the user of your class needs to know. And when they call it, that happens. So that is encapsulation. Very powerful concept in all object-oriented programming. Now we're going to go to the next one. Does anyone have any question so far? Question? Is it clear? Let me show the code again. Maybe. Um, so we have car. Maybe this is also a bit confusing. Let me just put them next to each other, just in case. So this is just a regular if statement. Is it clear? Okay, I'm gonna ask questions. So I'm sure because no one is answering. Obi, oh, Goswell, you have a question. Yeah.
Okay, so my question is this: the codes which are encapsulated, do you have a separate place you make up those codes different from the real execution of the code? Because I'm thinking of it like, let's say we have a big room, the room we can section it where we put the codes. Nobody can see
So
those codes. Then
the
the other
point
one
is,
is where the real
in your
job is
class,
done.
remember
So
this
I don't
is
know how that works.
so a class actually performs something. It has a job. Do you understand? It has a job. So like this car class, its job is to create a new car. It's the blueprint. It creates a new car. There are certain things you probably want to use while creating a car. Like you see, we try to use fuel, we try to combust, we try to somersault, we try to make a sound. Now, however you decide to partition it, you understand? If you want to put that in a separate class, it doesn't matter. The point is, when people want to use that class, they should only be able to access what you make available. Now, let me be very clear because I know there might be some misunderstanding when I use the word access. So the point is, the code is not actually hidden. So, like you say, use a separate room where it's hidden. No, it's not actually hidden physically. You, that is a programmer, you can always see the code. Like I can come, like you, that is a programmer, will come in here and you see that it's private. So the hiding is not a physical hiding. It's not hiding from the eyes. That's not the hiding. And that's not the encapsulation. That's not what it means. The hiding comes in the use. Do you understand? Just like the car that you have, if you open the bonnet, you can actually see most of the things that is there. If you turn it on, sometimes you can see when you turn it on, a fan belt is turning. You can actually see it. So it's not like it's the hiding is not from the physical eye per se, because you as a programmer you can always go into the code and say, oh, this one is private. You can always see that the hiding is when you want to use it, you don't care what is happening. Do you understand? So it's the same thing you see here when the usage in programming is when you now call an instance. Me now that is a programmer now, somebody wrote a car class. Of course, I can go into that car class and see everything inside. But when I want to use the car class that Goswill wrote, the only thing I have access to if I put car dot is start engine because that's what he made available to me. Every other thing I cannot access it. Take a look. If I try to access combust now, let me try to access combust. I do car.combust. Check this out. It doesn't know what combust is because Goswell did not make that accessible to me. This is similar to you wanting to start your car, but you put your hand inside the engine trying to turn something. Nah, the thing is either going to injure you or it's not going to work. It's not made accessible for you. That's not what you're supposed to do. That the manufacturer did not create that car in such a way that you have to turn it on, you have to open the bonnet and start turning something on there. No. It's not accessible to you. He made things that are accessible to you. The things he wants to hide from you, he hid it from you. So it's the same way you that is the user of this car class, even though you can see the bonnet, you can open the bonnet and see there's combust, there's somersault, you cannot access it when you try to use it. Look, you don't have IntelliJ. IntelliJ is even being nice to you because it's showing you don't have access. If you're not using IntelliJ, nothing will warn you, but you see that when you run it, it will tell you Combust has private access in car. It's private, you can't use it. The reason why you're seeing squiggly line is because you're using IntelliJ. Normally you would not see a squiggly line, but when you try to run it, it's gonna give you a warning and say, bro, Combust is not your business. You're not accessing it, it's locked away from you. What you do have access to is start, what's that again? Start engine. And when you run start engine, all those encapsulated stuff happens. So when you talk about hiding, so understand what I mean by hiding. Hiding is not from your physical eyes. No, hiding is from the usage. So it doesn't matter. You can put it in a separate room, like you said. In this case, separate room will be a different class, or you can, however you want to arrange it, but you hide it or encapsulate it. But me as a programmer, of course, I can see everything in the separate rooms. But the usage, that's where the hiding happens, right? All right. Okay. So let's go on.
Yeah, understood.
Let's see. So what's the next one? The next one is inheritance. So don't forget the word encapsulation. So encapsulate means you hide, you only make things available that are, you know, relevant. The things that are not relevant to the user, You hide it away. Now we'll move to inheritance. Now, inheritance is actually a mechanism that allows a class to inherit properties and methods from another class. And that's another class in that case will be referred to as a superclass. So what is that? Let's try to bring that to real life in code. So take for example, now we have a class. We have a class called car. And technically, you as a manufacturer, I manufacture cars. I realize that all my cars do the same thing when they want to start the engine. They get the fuel, they combust, they somersault, and they make a sound. And then the engine starts. So what if I wanted to create Volvo? So I have to write all of this again? If I and then I want to create a Volkswagen, I have to write all of this again? I have to create a Toyota. I have to write all of this again? Oh my God, that's like a lot of work. That's where inheritance comes in. You can actually inherit attributes from a superclass, from a class that is already existing. Now let's take a look at this. So we have a car class, and now we're going to create another class and say Java new class. Now we're going to have a Volvo, which is a type of car. So I'm going to say Volvo car. That's the name of my class. And then I would now say, since this is my Volvo car, I would say uh, extends car. How you guys seeing this? I just said extends car. That means go and inherit everything inside the car because I am also a car. Volvo is also a car. Now check this out. I'll go to my car manufacturer class and I'll say Volvo car is equal to new Volvo car. Uh, sorry. And let's see. So I have an instance of a car, but I don't have access to my start engine. Why is that? So let's take a look. What is going on? Cannot resolve method start engine in Volvo car. So okay, because I want to be able to access that method, right? So let's see what is going on here. Oh no, this is a different class. Let's go into this one. Start engine. So there's a problem here. What is the problem? No usage. Everything looking okay here. Start engine. So let's see. What am I missing? Oh, okay. Okay. So basically, what I'm trying to do is reuse the same properties here, but for some reason, I'm not gaining access to it. It's public, it's available, I'm inheriting from it. And so see this how you solve problems in Java. You know, something is going wrong, you're asking, okay, what is wrong? So and we're gonna figure it out. So I'm extending, which is good because with extends, you're actually inheriting. Now let's see if I'm doing something wrong. So I'm gonna create this. I'm gonna create a constructor. Oh, okay. All right. Let's do something else. Let's say public void start engine, um, which is quite similar to this one. Okay. From my experience, we don't need that. Okay. So now I have because I program mostly in C sharp, and now I've forgotten how to reuse the code. So let's go to Google again. So point is, you have to know what you want so you can ask Google the right question. So now what I want to do is I want to inherit a method from a class. So let's do that. Java inherit method. So yeah, I have to override it. I think that's practically what I'm missing. Yeah, I have to use the override keyword. Okay, no, I don't have to because I still want to use. the same stuff. Just give me a minute. Let's see. We extend. So this is us inheriting. Let's see. Public display. Okay. So I get it. So so what we have to do is we still need to we still need in our Volvo class, we still need to call the same method. Where is it again? Car. So where's the start engine? What is a different one? Different one. Car. Good. So we need to start the engine. Where is our start engine? Whoa. Where's my car class? Oh yeah, I was opening the wrong one. Car. Good. So we need to create this same method here. But since we are doing the same thing, or we want to do the same thing, we use the super keyword and we call the start. Oh, engine. I expected to gain access to it. Super. All right. Probably missed that again. Hmm. Okay, that is very strange. Okay, let me see. Do I have the right name? Start engine. Yes, I do. Okay, I think I was inheriting from the wrong car class. Let's see, Volvo. Oh, that's the problem. You're gonna see what's happening here. So you see, I have a Volvo. I created a very silly. So I have another car class somewhere. I think look at my car class that I created. I now have another car class in here. See, I now created a Volvo car, and the Volvo car is trying to gain access to this other car class, and none of those methods are in there. So that's what's causing the whole hiccup. So I should, um, yeah, I should be more organized. So I'm gonna move this Volvo class out of here because it's trying to access the wrong class. Now the Volvo is here, and I want to access this car class. That also means that it's importing from the wrong car class. You see up here, it's importing from OOP car, which is the in here, which is the wrong one. So I'm gonna get rid of that. Good. So you see our class is back. And I actually do expect, I did not expect myself to even write any of that. So let's see if my first implementation was correct. So I have a Volvo class that is extending from this car class where we have a start engine and we have a manufacturer. And yes, that's exactly what I wanted to show you guys. So now I don't have an error anymore. So what I wanted to show you guys, of course, is I extended the car class and now I don't even have any code in my Volvo class. But check this out. I created a new Volvo car and I clicked on start engine and I ran it and look, it did all that repetitive task for me. And that's inheritance. I don't have to redo it again as long as the what do you call it? As long as the feature is the same, I would just inherit from the upper class. But um what if in this car class we have this start engine um for um, for maybe let's say Volvo is an electric car, right? But everything is the same. Get fuel, combust, somersault, make sound. It's the same. But because it's an electric car, it does not start engine. It does something else, right? So how can we can we override that? Or let's say no, let's not say that. Let's say it starts the engine, but also does something else. Or let's say it starts the engine and starts the electricity, right? So is it possible to inherit and still adjust it to fit the particular class we're working on? Absolutely, it is very possible. And how do we do that? So that was what we also tried to do before. So now we go to the Volvo class. Now we see that we are inheriting from the car class. Then we create the same name. We can create the same name. Where's our car? So let's say we do the same start engine. So we have two start engines now. So we have start engine that is in the car, but Volvo also has its own start engine. So now we are kind of overriding. We want to override the original start engine. So what we now do is we now say something like super dot start engine. So what we are saying is still do the same thing that is inside cars, the super class. The car that we inherit from is the super class. Go there and start the engine still. And after you start the engine, we're going to do our own extra stuff that is like start electricity, electricity to just say started electricity. Now let's run this and see. So you see in our car manufacturer, we created a new instance of the Volvo car and then we started the engine. Now look at the Volvo class again. There is nothing like what we have in here in the start engine, but we are inheriting it. So you see, it saves us some code because we just inherited it. And then we added our own extra feature to it. So if we run this now, check this out. So you see, it performs all the inherited functions and then our own function too that says start electricity. And how did we do that? We used the super keyword, start engine, and then we printed out our stuff. And the only reason why we did this, or we are doing it like this, is because we want to add some extra behavior to the original start engine behavior. If you have a situation where you don't want to add any extra behavior, it's the same thing, then you don't need any of this. We just leave it the way it is. And even though you as a programmer will come in here and be like, oh, there's no code in here. Yes, there's code because it's inheriting from a parent. And that means you can also run it. And when you run it, it still behaves the way the parent intends for it to behave. And that right there is what inheritance is about. Your code should be set in such a way that the user can that you put in such a way that you don't repeat code you can inherit from other stuff, from other codes. Obi, you have a question?
Yeah, so the super keyword, is
So
it
this the super, you use the super
used when you want to only when you want to
whenever.
modify the code?
So the reason you
Is
use
that
the
where that
super
super keyword come, or is
is
it something
whenever you
else?
want to access the parent class. And the reason you're also using the super is because the current class and the parent class have the same a method called start engine and they are the same name. So using the super, you're telling the code, okay, I'm not talking about this super that is inside my code. No, I'm talking about the super inside the parent code. Now, this super is not would not be necessary if we don't have the same name. So if I made this start engine 2, for example, then I don't need this super keyword. It doesn't matter. I can leave it, but I don't need it anymore because now it would know that, okay, since I didn't find any super engine in this class, it must be from the parent class, and it goes and it checks and it finds it. So
Okay.
now this will also give you the same result. The only difference now is when you call super if you leave it at start engine,
Yeah.
right, like this, it will call that is from the parents. So if I run it now, you see there's no extra information. It calls that from the parents. This one exists already from the parents because you're inheriting. But if you make this now start engine 2, then the start engine 2 calls that of the parents but also adds its own extra feature.
Yeah.
So the super is indeed a keyword within Java. You only use it when you can use it if you want. If you can also use a super here, no problem. But mostly you see it's used when there is a method that has the same name as the method in the parent class. So it's just so in this case You see, you see what the problem is. It's telling you that there's one related problem. This super engine and this super engine, bro. What are you talking? What do you mean? Like, which is it? Because now I'm confused. So now it. I mean, the code is telling you I'm confused. I don't know because I have a super engine in the car class that I'm inheriting from, and you also mentioned a super engine. Then you're now like, oh no, I know exactly what I mean. I want you to go to the super and get the start engine from there for me. And then you have to go to your manufacturer class and change this to super engine. So that way you get exactly what you want. Does that answer your question? All right. So let's see. What is the next one?
Yeah, that's clear. Yeah, thank you.
The next one, let's see. So the next one is polymorphism. So what is polymorphism? So let's see if we can get a dictionary keyword for that. What is polymorphism? So let's see what is polymorphism. Okay, I don't want us to look at it in in the tech world. I want to look at it as a normal word. Yeah, so this is an explanation an explanation of a normal word. What is polymorphism? The word polymorphism means having many forms. A simple word can define polymorphism as the ability to of a message to be displayed in more than one form. So I think we also know, for those of us that have been gaming for a long time, we also know words like morph. You're like, yo, I'm this character can morph into something else. That means you can change the form. It can morph from reptile to like scorpion to be like different. So it's a term that maybe is it is a little bit familiar to me because I played Mortal Kombat a lot and I used that word morph when I was younger. So it's the same concept. So your code should be able, when using OOP should be able to allow the developer to morph behaviors. And what does that really mean? Um, we've actually seen that a bit here. So let's define it more. So let's do something like this. So here you see we have let me see. No, am I in the wrong place? Right place. Volvo. So here you see actually that we are extending from the class car, but the Volvo car, the Volvo car has also a start engine method, and now we have removed the super keyword from the start engine, and I think we also need to put in a keyword called a decorator. I think that is called override. I don't know if that's supported here. Override. And what we are practically saying is there is a start engine class in the car class, but we want to morph it when we're starting the Volvo. So let's see. So let's create another car. Let's create another car to make this a little bit clearer. So I'm going to duplicate this. I'm going to call this one Volkswagen. And this is not going to be overriding anything. What else? Why is it giving me squiggly lines? Let's see. Why is it giving me some errors? Shouldn't be declared. Oh yeah, so I have to put this in a different file. Let's see if IntelliJ can help me do that. More action. Yes, it helps me. So IntelliJ has helped me move the Volkswagen class into a separate class. So we have a Volvo and we have a Volkswagen. Now let's go to our car manufacturer, and now we're going to manufacture two cars. So we're going to manufacture a Volvo and a Volkswagen. Volkswagen. I'm gonna call this car two. Car two. Volkswagen. Now take a look. So let me make this clearer. So we have two cars. We're creating an instance of two cars. The first car is car one, second one is car two. Now if we run this now, let me just put a space between them so it to be clearer. Um, system.out.println. Just put two spaces between them so it's our printout will make more sense. So if I run this, now take a look. So the first one we ran was the Volvo car, and we said start engine. And check this, it just printed start engine. And the second one was our Volkswagen class. Still, we called start engine, but the behavior has morphed. It's different. It gets fuel, it combusts, it somersaults, it makes a sound, and then it starts engine. But we are calling the same method, and we are inheriting from the same class, which is car. Both of them are inheriting from car. But because Java supports OOP, it allows you to morph a method to behave in a different kind of way. And this is very important because a lot of times you have um, you have uh, an entity, or you have an entity, and that entity has different types of that same entity. I'll give you an example. If I say bird, yeah, your brain will just go to different kinds of birds. So we have duck, we have canary, you have chicken, you have goose, you have so many. All of them are birds. But the point is, even though they belong to the same class, they have certain behaviors that are not the same, right? So, for example, walking. Not all birds walk the same way. A chicken walks one foot in front of the other. So if I had a method called walk for a chicken, the walk of a chicken will be one foot in front of the other, one foot, almost like a human being. But a raven, that is also a bird, if I have a walk class, a raven hops. If a raven is working, it hardly walks one foot in front. It just hops, pump, 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 pump. A canary also, I think, hops. It doesn't walk like a bird. So even though they're in the same class of classification as birds, they have peculiar behaviors that are different. For example, sound also. If I say canary, make a sound, you probably hear a very sweet sound. But if I say duck, make a sound, a duck would do quack quack. So if I had a sound, a make sound method, I have to be able to morph it depending on the kind of bird. So one bird, if I say sound, should make a different kind of sound compared to the other. You get it? Now, there is also another way to implement uh, polymorphism. Another way to implement polymorphism is actually using what we call interfaces. So let's look at that. What does that look like? So I'm going to create a class. Actually, it's called an interface. You can see it here, interface. So why is it not working? Oh, I have to put a name. So an interface, yeah, I'm used to naming interface with the word I and the name, the class that I'm going to be using it for. So I'm going to call this an iCar. Then um I'll create a method or whatever I think needs to be different in various um in various entities that will use it. What do I mean? So I'm gonna create start engine here. Start engine, and this ends here. Now, this example I gave here, okay, see I've made the same mistake again. I'm saving it in the OOP class. So I'm gonna take this out of the OOP class again. I'm gonna save it the right place, refactor, close this. So I have a a car class, an interface here. Remember the word interface. An interface is more like a contract. It's an agreement that you are giving to a class that certain methods must be created. And I'm going to explain what that means. So we've seen classes now that this is an interface. Now, how do we use it? So I gave you this example between, let's close all of this again so that I don't confuse you guys. So we have a Volvo here, and we have, what was the next one? A Volkswagen. Volvo. Yeah, we had a Volvo and a Volkswagen. Now I did an override for the start engine class, right? And if you look in the Volkswagen, I didn't write any method, and the Volkswagen just inherited from the car class here. And the reason why this was okay is because we assumed that there are more cars that follow this convention, right? But what if we are sure that every car starting process is completely different? The only thing that is uniform across all of them is the act of starting a car or starting an engine. But the way Volvo starts is very different from what Volkswagen. In fact, we are sure that all cars start differently. Then you see it would not make sense to create a start engine method in the superclass. But you do want every car to have a method called start engine because that's one thing you know all cars have. All cars must start engine. The only difference is they start their engine in different ways. So how do we make sure that whoever is creating, whatever manufacturer, whoever that is creating a car that is using our car superclass must implement his own start engine? And we do that with interfaces. So now I'm going to get rid of this start engine because now we are sure that there is no start engine. Sorry, we are sure that every start engine is different, but we want to make sure that everybody implements a start engine. How do we do that? We now come to the car class and we use the keyword that says implement. Now we put our iCar contract. So you see, let's look for the iCar. So you see, in this iCar contract, we said anybody that is implementing this iCar must create their own start engine. So sorry, I put the implement in the wrong place. Sorry, it's not supposed to be here. We're gonna put it in the Volvo class itself. So we're gonna say we extend from the car class, and then we implement. Am I doing it right? Sorry, implement iCar. So when we do it this way, we are forcing, yeah, maybe let's do it differently just to stay clean. Let me see. Yeah, okay. I will leave it this way. So we are saying that everybody that is using this iCar um, interface must implement a start engine. And we have also said the start engine must be of type void. So let's look at what's the problem. So it's telling us now that since we have, let me see, what is this saying? So I think we have one of our classes, yes. So our Volvo class does not have that implementation in it. So let's take a look. So it's saying that we have to implement that too. So I'm going to copy this. Just a minute. Okay, no, sorry. The reason this is giving this error is because I commented out the start engine from here. So it doesn't have access to it anymore. So let's get rid of that. Start engine. But take a look at what we're going to have as a problem now. So if we have this Volkswagen extends car, then we do something like this. We say something like implements iCar. And guess what? It's now saying, bro, you want me to implement iCar, but there is something you must do. You cannot just implement iCar. You must create a start engine. And that's where polymorphism is also taking place because now we see that Volvo has its own. Now we don't need to use this override anymore. So we see that Volvo has respected it because it has an iCar and it has a start engine, but Volkswagen has not respected it, and that's why it's saying error. So now we're going to use IntelliJ's stuff and say implement method. So it's going to create it for us. So it creates that, and we have the start engine uh, method, and then we can do our own version of start engine for Volkswagens. So we can say maybe Volkswagen when you start it does a beep beep or something. So say do something like this and say system the print ln beep beep starting engine. So this is also a way we can implement polymorphism, and now that we have start engine on both of them, if we run it, we'll see that even though we have um, a start engine um, method, they morph. It's different for every single engine. It's different. So we've seen two ways you can morph it. You can have it in the original um, class and then morph it by overriding it, but you can also use contracts or interfaces. Now look at the structure of an interface. An interface does not have a body, you see? It's just one line. You can also have Boolean. You can also have of different. The front is the return type, huh? So you can also have another one and say this must have uh, you must implement a method called has it started, and now you see that I added this code to it. Sorry, Boolean. So you see, now that I added this code to it, all these other classes will start complaining. So we'll go to Volvo. You see, Volvo is complaining. Volvo is like, yo, you didn't, there's something else you must implement. So I implement it now. And you see, we have it has started. Then we'll go to Volkswagen. It's also complaining like, yo, because of you implementing this contract, there's something you must implement as well. So implement that. And you see, we have it. And then the error is gone. So we use interfaces to make sure that multiple classes that have similar behaviors but have a certain method that should behave differently to have its own implementation, we can enforce that using interfaces. And that part is polymorphism because using interfaces, we can morph the behaviors so they can act differently even though they all fall within the same class. Questions? If I Yes, yes. In Java, you cannot extend from multiple classes.
My question
So we
is, in
cannot
Java,
have. So let's
we
say we
can
have.
only inherit from one class, right?
What
And
can we
implement
say? If we had another
multiple
car,
interfaces.
so you cannot extend from more than one class, but you can implement from more than one interface. So if we had another interface, let's just duplicate this. Call this car two. This is an interface. I remember our contract. So call this engine two. Started two. So if I go to the Volvo class, I can inherit also from iCar2. And then that also means I have to implement everything that is in iCar2. See, because of I extended, then if I put my mouse and I do implement, so you see it's brought this extra methods in and said, bro, you have to implement this because you also have to respect the second contract. But we cannot extend from multiple classes. So if I say superhero, you should have a superhero class here now. Or let me just let me try something else. I'm gonna create another car class. No, I'm gonna create another Volvo class. Oh, sorry, Volkswagen. Call it Volkswagen 2. I'm not going to inherit from anything. It's just an empty class. So if I save this, let's go to our Volvo class. If I say comma, if I say comma Volks, so it's not even working. You see that Volkswagen. So you see, it's not possible. See, it says cannot extend multiple classes. So you cannot inherit from more than one class, but you can implement more than one interface. So that's a correct observation. Any other question? All right, shoot if I. Yes, that's a good one. So method overloading, what is that? Okay. So
Uh,
method overloading is
Method overloading
actually
can it also be considered
what we
as
did before. Let me get
polymorphism?
rid of this. So method overloading was exactly what we did with the here. So we had a start engine class, a method, and which is in the car class, and we had sorry, where's the Volvo? We had a Volvo car, and we have a start engine here. So if I got rid of this and I get rid of this and I say override, sorry, override. Okay, sorry. Overload. I'm mixing it up. Overload is actually something different. So this is overriding a class, a method. Sorry. Uh, what am I? Let's try this. Override. Let's see. Why is it giving us squiggly line? Identifier expected. Oh yeah, I think it should be something like this. So sorry, I misunderstood you. So we have two words that are sometimes very confusing. So you have override and overload. So override is what we see here. So we have a method, which is also part of polymorphism, and um, and we have overload. Now, to come back to your question, is overload a type of polymorphism? I would say yes, but I'm not sure. I don't know if those who define these words will consider that polymorphism, but I do consider it polymorphism because you also change a behavior. Now, let me show you guys what method overload means. So, method overload is simply having the same name. So, I'm going to go back to cars. So, we have here in the cars stuff, we now have another start engine. So, normally it wouldn't even allow you. So, say we have public void. So we have another um, class with the same name, but this time we add uh, we add a property to it. So you see, this is allowed in Java when as long as the both classes are somewhat different. So now I'm going to say something like this: system.out. Sorry, this is showing squiggly line because this should be so system.out. The print ln. I'll print. Let's print the car name, and then I'll say start engine. Start engine. So this is called method overload. And simply because you have the same name of method, but one of them is accepting certain kind of parameters. You can even have, we can even do another one. And this time maybe we'll make this an int. So you see, because the data type is different, it allows you. So we'll call this number, say number of pistons, and I'll say piston, piston plus piston, no, sorry, number of piston. So you see now that when we want to use this stuff, so first of all, understand this is called method overloading. We have three methods of the same name allowed completely in Java, but you must make sure that their parameters are different. See, the parameters are different. But we have three of the same of the same name, and they are slightly different in different behavior with different behavior. I wouldn't know. I'm not really sure if you this is really classified under polymorphism. I would say yes, like I said, because there's some slight difference in behavior. Um, so how do you use this? It's just very simple. We go to the car manufacturer. Uh, Now we can that means like Volvo now has like three ways you can start it. You can start it with the normal Volvo way, with the default Volvo way, or we can do something like this and say start and put, because one of them accepts a string, and we can say dolls car. So you see when we run it now, let's see. So you see when we run it this time, it prints dolls car and starts engine. Or we could do the piston one where that accepts an integer. I'll say this one has 100 pistons. See, no, you see, it's smart. It knows that since I gave it a number, it has to use a different method of the same start engine. And then when I run this now, you see it says piston 100 starting electric 2. And then you can just go to the default one that takes no parameters. And when you run that, it just says starting electricity 2. So that is method casting. Sorry, overload. Sorry, and that is also allowed in Java. Any more questions? No. So the last one is abstraction. Abstraction is actually very similar to encapsulation, and basically, abstraction is actually what we also saw, which is yeah, you abstract away uh, methods that are private so that they're not accessible. Let's see, is there any other way? Abstraction also happens. Sorry, I'm taking a look at my notes. Yeah, so abstraction happens also in a different. Okay, so let me give an example of an abstraction that could happen. So take a look at this. In this class, or sorry, show you an example of how what an abstraction looks like. So in this example, right, we can create a new instance of a car. So see, car cc is equal to new car. You see this? And then I can say cc dot start engine, which is our car class. So, but remember, our Volvo also inherits from car class, but that's not what I'm calling right now. I'm calling the main car class, right? And the start engine works. If I run it, we see this is our start engine of the main car class, right? But what if the word car is just too abstract, which it is, right? It's just like if I said bird. Bird is very abstract because there are 1 million, over a million birds. Okay, maybe not, I don't know, but there's a lot of birds that fall under the word bird. So if you say, okay, I want to create a bird class, that's very abstract. Like, yo, what bird, right? It's the same thing for car. I want to create a car. Okay, what car? The word car is abstract. So you want to set up your code in such a way that abstraction can be used so that when the user wants to develop, he cannot just be creating a new instance of a car, but has to be specific what car he wants to create. And how do you do that? Now, if we go to the car class, we just use a simple keyword called abstract. So instead of public class car, we put abstract in front of it. Now, there's a thing with an abstract class. The cool thing about, or maybe not so cool for some people, but it's absolutely cool in object-oriented programming. The cool thing is you cannot create an instance of an abstract class. It's not possible. That's why you're seeing the one in here, because if we go to our manufacturer, you see I'm creating a new instance, new car. It's saying, no, this is an abstract class. The only thing you can do to an abstract class is inherit. You cannot create a new instance. You can only inherit from it and inherit all the features it has. So check this out. So it says car is abstract, cannot initialize. So fine. Bam, this is gone. But check this out. Volvo is just fine. And why is Volvo just fine? Volvo is extending from cars because that's what an abstract class is. It abstracts implementations away from you, but make sure that you cannot create a new instance of it. So this is like extra security so that people will not make mistakes. So you that is programming, if I wrote this software, I want to make sure you don't make mistakes and think you can create a new instance of a class. I don't want you to create a new instance of a class. Anytime you want to use a class, create an implementation and extend from the car class so that you can use all the cool features I have inside, just like the start engine method. So that's what abstraction does. So abstraction makes sure that you cannot create a new instance, but you can inherit from it. Another cool thing you can do in abstractions is the same thing we did in interface, we can do here. We can say, okay, and you can do this only in an abstract class. You can say, fine, start. I'm going to help, since there's a lot of start engine that are similar, I'm going to create all the start engine for you. But, but moving, I'm going to create a method called moving, but that moving, you must implement your own version because every car moves differently. So, we did the same thing with interfaces, but you can do that in an abstract class. How to do that? You just do something like this. First of all, you figure out what is the return type. So we're going to make this void, and we'll call this um, moving. And I think we have to make this public, I guess. Let's see, what am I doing wrong? Missing body method. Okay, I think I am. Okay, I think this is abstract. Public abstract. Yeah, I think I have to keep put this keyword exactly. So you see this? I just created an abstract method here, and that means that if we go to Volvo, Volvo is now like, okay, there's a problem. I'm extending from car, but it's forcing me. It's saying there's something I must implement myself. So I'm going to use IntelliJ to do that. Okay, you see, it creates the moving for me. It's saying, okay, you now have to create the Volvo version of moving. So I'll say, okay, fine. I'm gonna do my own Volvo version of moving. So I'm gonna say Volvo moving. And when you go to Volkswagen as well, it's saying the same thing. You must implement. So let's get rid of the iCar. Get rid of the override, and let's see, get rid of this one as well. And let's see, we implement, and it's saying you must implement your own version of moving. So I'm gonna say stop moving. So say moving Volkswagen. So that way now in our car manufacturer we can use all of that. So I'm gonna say C2 dot moving, and we can come out here and say let's make this just one. So we can come here, we can say car dot moving. So both of them now have their own implementation. Moving Volvo, I'm moving. Volvo moving. Moving Volkswagen. I think I spelled the moving wrong. But yeah, that is how you abstract away. So The point is object-oriented programming. These are the four concepts it has. We've seen the different ways you can implement it. Uh, any programming language is any programming language that does not allow you to do these four things I've just shown you is not an object-oriented programming language. I repeat myself. Any programming language you programming that does not allow you to do these four different things is not an object-oriented programming language. And we have a lot of them out there. So this concept is what makes an object-oriented programming language, what makes a language an OOP language. And you as a programmer should know that these possibilities are there and you can utilize them to make your code much more readable, maintainable, and all of that. Now, are there any questions? All right, no questions. So I will, let me see, I gave you guys this page last time. So I would really advise you guys to go through all of this stuff. And this will be probably the last, um, um, this is the last topic that I'm covering for the Java basic fundamental class. Um, And next week, I do hope, hopefully, when we're here together, I would do like a small mock exam for you guys. So prepare. And when we do a mock exam, that way we can refresh our memories on what we have learned for the past few months. And then after that, we will move to um, Spring Boot, where we will actually try to develop a web application using the things we've learned, which is Java. You will learn some new things. You also come across some things probably that we didn't cover, and but you now have the fundamentals that you need. You have like the building blocks. So don't forget what we've discovered. You guys have learned a lot. Think about it. You've learned about data types. You've learned about variables. You know how to initialize variables. We dived into object-oriented programming. We learned what the main method is. Main method is a gateway to your program. Um, we've learned so much. You understand? But don't forget, it's the fundamentals. That is your ABCs. That is your building block. That's what you're going to stand on. So please revise it. Ask questions, um, because now we have to start working on it, on what you have learned so far. We want to start seeing if we can build something. And one of the most popular things you can build is a web application. Um, and yeah, like I showed you guys last time, building web applications using Spring Boot is in high demand. There's kind of a learning curve to it. To learning Spring Boot, there is a learning curve, but you will see a lot of Java codes there. You'll see new Java codes that you didn't know were there existed, but the foundation you get, you'll be able to understand some stuffs better than if you never took this training. But ultimately, I want you guys to start finding your way up from there. And for those of you that really want to be programmers, I am only a guide. I am just showing you the way using a touchlight, but the person that's actually going to climb the mountain is going to be you guys. And learning programming is has to do with to me. I'm going to tell you how I did mine: discipline, consistency, and practice. You understand? It's going to be frustrating sometimes for you, but you guys are very fortunate. You have me. You're totally fortunate. Like you can always reach out to me. I'm not like the most prolific programmer in the world, but I'm not that bad. I'm pretty good. So there's probably a lot of questions you ask me that I probably like. There are a lot of stuff you can ask, and I probably will know the answer to. And if I don't know the answer, I know how to find it for you. So that's also very good. So Chinonso asked me a question last time, like, or was it Chinonso or one of you, like, yo, is it allowed to use Google when you actually have a real job? Yes, but the difference is when you're a programmer, you know exactly what to look for. So you saw me now, like when I was working with you guys, I wanted to do something. I had a number and I wanted to pass it into a method, and the method was only accepting string. So I know what to do, look for. So what did I do? I typed convert int to string. But if you don't know anything about strings, you don't know anything about conversion, you don't even if you don't even know that a string cannot take an int. What? Tell me how you're gonna use Google? You're gonna be like, I don't know what to type. I don't know what to look for. You get it? So it's totally okay to use Google, but the difference between you guys or people that know how to program is you would know how to use Google to solve your problems. So nobody knows everything of like everything. You guys are still gonna learn a lot, but yeah, if you hit any hurdle, even if I don't know the answer, I know probably how to get it for you. I know the right keywords to search for. I know the names of things. That's why I'm introducing to these names: abstraction, polymorphism, variables, instance of a class, object. Those words are words you're going to use when you're searching on Google. If you don't use those words, Google will not know what you want. For example, if you want to know how to use this line, say you have a class, right? You have a class and you want to use it to say car dot, and you don't know how to write this line. Look, you don't know how to write this line, but you want to use the start engine. How are you going to tell Google that this is what you're looking for if you don't know the names? So what if, since you've gone through this class, you know that, oh, you need an instance of a class. So this is an instance of a class. There's also another name for this. This is also called what is it called right now? I can't even remember. So this is an instance. What other term do we have for it? Okay, for now, instance, right? Now check this out. Since you know that keyword, you know that name, you can go on Google and say, how do I create an instance of a class in Java? Check this out. Java is Google is just gonna show you this is how you do it. But if you don't know that word instance, how are you going to ask? How are you going to find it? Like, you're going to be like racking your brain the whole day. That's why it's good to learn programming. But it doesn't mean that because you learn programming, you're going to know everything. No, you're not going to know everything. But you're going to know how to use Google. You're going to know how to ask the questions. You're going to know how to look for what you're looking for. Because you know a lot of keywords, you know a lot of terms, you have an idea of what you want, and all that you're going to use that to query Google, and Google give you what you want, and you keep building on those knowledge on that knowledge. You understand? Today you've learned inheritance. You can say, how do I implement inheritance inheritance in my Java code or application? Check this out. Now you look through it, inheritance in Java, you look at it, and you see they show you use the word extends just because you know what you're looking for, because you know the name, you know the concept, you know stuff. You come here, you see superclass, subclass, all of that. You look at this, you see extends, extend. You're like, oh, I remember it's extends. Yeah, I have to extend, and you go. You see, this is very similar to what we did. A car class, vehicle extends. So that's the benefit of taking the training. It's not that you're going to know everything. I really don't know everything, but I know a lot, but I don't know everything. And the things I don't know, I know how to find. And that's what you guys are going to be doing. In your offices, when you're working in the real life, that's what you're going to be doing. You're going to forget a lot of stuff that we've done. You forget a lot of instance, but you have an idea. You're like, what is it called? What is it called? You use that to look for it in Google. And once you get it, or you're like, oh yeah, I know it's this is it, and you use it. So that's how it works. And over time, you probably would need Google less, but because you know a lot, because you do it often, you just keeps coming and coming. But yeah, Google is your friend. Use it. Everybody uses it. I am. I've been programming now for over 20 something years. I still use it. I literally still use it. And you figure out as time goes on, your next best friend will be ChatGPT because ChatGPT can program pretty well. But you have to know what to ask it. So if you ask it the same questions we're asking Google, it will give you a very good answer. Any questions? So let it sink in. You're gonna come across this four. You're gonna come across these four concepts in a lot of other programming languages. I'm sure some of you might be into JavaScript. I'm not sure JavaScript is fully object-oriented yet, or maybe it is. I don't know. Definitely, I know Python is. So if you're taking Python trainings, you come across this. Any language that claims to be object-oriented programming language, they would have to be able to implement these four concepts. If you're taking trainings as well, I mean exams in Java, you might get these questions as well, like what are the four concepts of object-oriented programming: encapsulation, inheritance, polymorphism, abstraction. That's it. So I'd like to thank you guys uh, for this for attending the training. You guys have a lovely weekend. I didn't prepare any assignments for you guys, but please revise your work, watch the videos, and yeah, I hope you guys had a good time learning the fundamentals. Right. You have you have a good one. All right, good weekend. Bye.